Okay, take two. Ready, set, go. So I thought the first useful thing to do would be to review this binomial random variable things. This is on your quiz, and I just wanted to do a couple harder examples and remind you how you can use Excel to check your work or do some of your homework. So the thing with binomial, remember, there had to be, binomial means that there's two possible outcomes. There's success and there's failure. So you have n trials. P is equal to the probability of success. And those are the things that, and also one additional requirement is that the trials must be independent. So like supposing you were like doing like a medical study, testing like how effective some drug is, you can't test brothers and sisters because those, they're, you know, that would be related somehow and they would affect the results. So we didn't go over this in class, but it's not very hard. The mean is given by number of trials times the probability of success. And this standard deviation tells you how much variability you would expect in samples of size n. How much deviation from that mean. Okay, so example, suppose you have 300 people and probability of success is 3. So for example, this might be the distribution for X is the number of people that have a genetic trait, like we could say the blue-eyed people, for example, and the probability that you're blue-eyed is 0.3. Suppose you have sampled 300 people and given this, find approximations of the mean and sigma. So mu is equal to NP, and the N is, and the P is 0.3, which I believe works out to be 90. Does that make sense? So you expect 90 out of 300 people to have this trait. And does that like make sense with the fact that you think 30% of people have this trait? That's 30% of your sample size, right? So that's what the mean is. What if that P had been 0.5? What would this mu be? 150. 0.5 times 300 or 150. Now the sigma, so that's root NP1 minus P. So root N, which is 300, P, which is 0.3, and what's 1 minus P? 0.7. And that doesn't come out nice, but I got approximately 7.937. Just double check that you got that too. Yeah, okay. So what that tells you is that if you take samples of what size? What size are we taking? 300. 68% have 90 plus or minus 7.937 people with that trait. People with, because every single sample isn't going to have 90 people exactly. Does that make sense? So there's going to be some variation in your samples, and this tells you how much variation to expect. What do you think happens to the variation, or the sigma, as the sample size gets bigger? It gets smaller. Does that make sense? As that sample size gets bigger, this standard deviation is going to be smaller relative to the, like it might be a bigger number, but relative to the sample size, it'll be smaller, I think. Okay. So that part's not very hard, right? Just plugging numbers into formulas. So a random sample of 1,000 eligible voters is drawn, and X is the number who actually voted in the last election, and it's known that about 60% of all eligible voters did vote. So what is your N? 1,000. What is your probability of success? 0.6. We'll assume success is voting. Okay. Okay, using statistical software, Excel, or a graphing calculator to find the exact probability that 620 or fewer individuals in the sample voted. So that's probability, that P thing. X is, how is X related to 620? Less than or equal to, bigger than or equal to? Less than or equal to. And I think their calculators might have a way to do these probabilities. I just don't know how to operate them, and they're probably all different. Technically, this means you have to do the probability X is 0 plus the probability X is 1, all the way up to probability X is equal to what? 620. Okay, I'm not going to obviously make you do this on a quiz, right? Because that's like 621 different factorial things, right? The way you put this into Excel is you do binom dist. You put in your K, your N, your P, and then there's a true or false. And some Excels might also do 0 or 1. Like my answer key says Excel uses 0 or 1 for true and false. I don't know which means which, but I think 0 is true and 1 is false, but I don't know. You have to check your own software. So K is equal to 620, N is, P is, and this one case you say true, and that's because of the true tells it to go less than or equal to. And one kicker about Excel is it only does less than or equal to. So if your inequality had gone the other way, you'd have to do complementing arguments. Okay, so when you plug this into Excel, you get 0.907. And there are a couple homework questions where you need to use technology to do these things. If you don't have Excel, there's freeware called OpenOffice, and I'm pretty sure that works in a very similar manner. Google Sheets, yeah, does the same thing. Like, it's not like you have to use Excel per se, but something that does this. Okay. So a pharmaceutical company claims that only 20% of those taking its new allergy medication will experience drowsiness. Of course, I'm one of those people. To test the claim, they assign 500 people to take the new medication and measures X equals the number of people who experience drowsiness. So find the mean and standard deviation. Okay, so first of all, what is N? 500. Great. And what is the chance of success, assuming success is you get sleepy? 0.2. Okay, so mu is NP, so 500 times 0.2, which is 100. So in a sample of 500, you expect about 100 people get drowsy, which is 20%, right? Okay, so then the standard deviation is root NP 1 minus P, so root 500 0.2, what's 1 minus P? 0.8, great. So that's square root of, well, I don't know what it's root of, but I know what it comes out to be. Did anybody get it?
It's 8.944.
Good, 8.944, that's what I got. Awesome. Okay. Using statistical software to find the exact final probability that the number who experience drowsiness will be 110 or more. So that's P of X bigger than or equal to 110. Do you guys agree with that translation into the probability statement? Okay. Now, Excel won't go that direction. Excel does less than or equal to's. So you have to do complementing. And with things like this, with discrete probabilities, you've got to be careful about equal to signs. They're not important when you have those PDF curve things, but they're important with stuff like this. So 110 or more is 110, 111, up to 500, right? So what are all the numbers less than 110? 0, 1, 2, 3, up to 109. Do you guys see what I'm saying? So be careful about that. You could also say less than 110, but then you have to know that 109 is the number you give to Excel. Okay? So just to do this part, so px less than or equal to 109 is binom dist 109, 500, 0.2, and true 0.856. That's just for the 109 part. And so your actual thing is 1 minus that 0.144. Okay. So the last thing that we're talking about is officially is section 8.8. We're talking about sums, differences, and combinations of random variables. So like this is like that you have two variables that are added together and you want to find the mean of that sum. You can just add the mean of the first plus the mean of the second. And the same thing is true for the difference. And mean and variance have this property that things are linear or additive and stuff can factor out. Standard deviation does not. Like it's not the same way, and I didn't write that on purpose. So if I ask you to find standard deviation, you use the variance, and then from that get the standard deviation. So remember that standard deviation is the square root of the variance. And I think this is best explained with an example. And this applies if one sort of special thing about random variables that are normal, if you have independent normal random variables, then when you do things called linear combinations, which means like you add one to the other or multiply by numbers, that's being linear with them, that you have something that is still normal. And that's not always true for other things. Like a binomial plus a binomial isn't always a binomial. Only there's specific conditions. Normal curves are special. Like they have this special property. You're not asked to prove it, but just that they are actually just a little bit special. So here's an example. I think this is a really good one. Suppose the length of time it takes a person to use an ATM machine is distributed normally, and the mean is 100 seconds, and the standard deviation is 10. And there are 4 people ahead of you in line waiting to use the machine. And you're concerned about the total time for the 4 people to take for you to use the machine. And that's kind of like a combination of 4 weights. Does that make sense? It's weight 1, weight 2, weight 3, and weight 4. You've got to wait for each person. So the mean for T will be weight 1's mean plus weight 2 plus weight 3 plus weight number 4. And what's the average time he's going to wait for the first person? That's the standard deviation. 100. What's the average time I'll wait for the second person then? 100 plus 100 plus 100, right? They all happen to be the same, right? Because we're talking about just repeated iterations of the same process. So that's 400 seconds. Okay, so the mean is easy. The standard deviation is a little bit hard because you have to go back to the variance. So what is the variance for one weight?
10 seconds.
That's the,
Sorry.
yeah, that's okay, no, it's fine, no, I apologize. So, oops, I added an extra 0 there, now I'm sorry. Okay, for one weight, sigma is 10. That's the standard deviation, right? the variance is, someone said it, is sigma squared or 100.
Which just happens to be the same.
Which happens to be the same as the mean. That is a coincidence. It's not always true, okay? That is, I shouldn't introduce problems that have coincidences because it makes you think there are patterns that are not present. So I'm going to call the next thing sigma sub t squared. What is my little subscript of t standing for? It's okay, time being the total time, right? As opposed to just for one weight. And that's going to be your variance for your first weight, your variance for your second weight, your variance for your third, and your variance for your fourth. And I just did 1, 2, 3, 4 on those little sigmas just for saying like it's your first weight, second weight, third weight, fourth weight. But they're all the same thing. What are they all? 100. So this adds up to 400. So then the standard deviation of your wait time is equal to root of 400, which is, what did you get? I think that comes out nice. It comes out to be 20. Okay, one thing. Just point out that it's not sigma plus sigma plus sigma plus sigma. Do you see what I'm saying there? You can't get the standard deviation of this linear combination by adding the other standard deviations, because that would have been 10 plus 10 plus 10 plus 10, which is 40. So to find the standard deviation, you have to go back to variance and then re-square root stuff. It's because square roots don't distribute. There's a technical reason why that works this way. Okay? So the most common mistake is people assume that, oh, if I want to get the standard deviation, I can just, add the standard deviations together, but you can't. You have to go back to the variance definition. Does somebody have a question? Okay. Alrighty. That's not so hard, is it? Okay. So Jackson hopes that his total time is less than or equal to 360 minutes, or 360 seconds, which is 6 minutes. Find the probability that this total time is less than or equal to 360. So what you can use here is you have a new normal variable, and you just found its mean and standard deviations in parts A and B. So what is the new mean? Yeah, mu sub t is not 360. What was the answer to A? 400. That's your mean for total time. What was the standard deviation for this guy? 20. And that 360, that's the, x. Does that make sense? So if we want to find the probability that t is less than or equal to 360, and we have a normal thing, that's where we use those tables, right? Like we did on Friday. That was Friday, right? So long ago. So we have to standardize this. So x is equal to 360. So your z is 360. I think it comes up pretty nice too, doesn't it? PZ, yep, -2. And you look at your table, which you should have if you're quiz today, and you get, I got 0.0228. Yep, -2. So his chances of waiting less than 6 minutes is just 2.28%. He's probably going to be waiting there for longer than that. Okay, so that's how you combine random variables that are normal. We're not going to do anything significantly more complicated than that, okay? So if you have binomial random variables, in general, and you combine them, is generally speaking not another binomial random variable. And the only exception is when the probability of success is the same. In that case, you can think about putting those things into one big trial where the success rate is the same. But the problem is if you take two random binomial variables, one could have success rate 0.5, one could have success rate 0.2, and there's no longer one overarching success rate. So to make it binomial, you have to have this one big overarching success rate that applies to both things.
So would that be like flipping 2 coins?
Yeah, like flipping two, like you flip 2 coins and I flip 2 coins, we could combine those into one experiment that's flipping 4 coins. Yep. You could technically speaking combine like flipping coins and having kids and do an experiment too, because like they have the same probabilities of success. So anyhow, I mean, you could think about them as trials where success is defined as heads or boy, but the kicker is same success rate. And here's an example. So we have 2 people, they're Isabel and Taylor, and they're working on a group quiz that has 15 multiple choice questions. Why the teacher gave them a group quiz, I don't know. And each of them has 4 choices for the possible answer. Neither had time to study, so they decided to randomly guess, and Isabel guesses answers for the first 7, and Taylor guessed the other 8. It's a take-home quiz, group quiz, seriously, what's wrong with them? Okay, moving on to my judgment. Okay. For a single question on the quiz, what's the chance of a correct guess? 1 in 4. Mhm. 1 in 4, which is 0.25. Yeah, we've done a lot of multiple choice, like true, false, but this one definitely said 4 choices. Okay. Suppose that X is the number of correct guesses that Isabel makes. So it's a binomial random variable. What is N in Isabel's case? 7. And what is P in her case? 0.25. How about Taylor? What's N for this person?
8.
And P is still 0.25. And because those P's are the same, you know that if you combine them into one big trial, it's still binomial and you have the same success probability. So consider X plus Y, which is the total correct guesses that they make together. What are the values for N and P in this case?
N is 15.
Mm-hmm. And P is still 0.25. And then how do you know that it's binomial? And it's because the success probabilities are the same. That's why. If for some reason one of the people had done questions that had 5 answers instead of 4, then it wouldn't be binomial anymore. But that would be a silly situation where some questions have 5 choices and some have 4.
Yeah. But it's also take home
what do you mean?
quiz.
So this is binomial because they were guessing on questions in the same test and they were all 4 answer multiple choice, right? If some of them would have been 5 answer multiple choices and had different probabilities, or suppose one person did all the true false questions and one person did all the 4 choice ones, then it wouldn't be binomial anymore because the success probabilities are different.
Oh, yeah, because
So it's not binomial because there's 4 choices, it's binomial because each of the 2 individuals has the same probability.
It's because when you look at answers C and D, or B and C, excuse me, the P's are the same.
Right.
And
That's the reason. Yep.
wasn't part of the definition too, like, there's a success and a failure?
Yes.
So even though there's 3 failures, they're still all failures. I'm
I'm not sure I understand what you're getting at, but
Yeah, my words sound weird, but.
yeah. Okay. All right. So last one. So give the mean, variance, and standard deviation of the sum in the following cases. So these are actually not that hard. And you're assuming they're independent. And then if you have things where you can name what happens to the sum, like is it still normal? Is it still binomial? Like you can say those things. Otherwise you can say nothing. So suppose you know that X is binomial, N is 10, P is 0.5, and Y is also binomial with N equals 20 and P equals 0.4. Yeah, so first of all, is X plus Y binomial, yes or no? No. X plus Y is not binomial. And that's because the P's are different. Okay, but you can still talk about the whole mean, variance, standard deviation. And here's how. The mean of X plus Y is going to be the mean of X plus the mean of Y. That's one of the things we had on page 2. And how do you find the means of binomial random variables just on their own. You just do NP, right? So this first, the mean of x will be x is n, which is, x is n is 10 times 0.5, which is indeed 5, yep. And then how about for y? Times,
0.4. Just 5.
which is also 5. Yes?
Yes.
I got, right? I got 13 somehow, but sure, my answer is just,
I got 13 too.
what, so that's definitely 8.
Yeah.
Yeah,
Yeah.
Yeah.
because 4 times 20 is 80, decimal goes over once, it's definitely 8, yeah. So the mean is 13. So you got 1. Variance of x plus y, that's equal to variance of x plus variance of y. Oh, you gotta think for a second here, because we know that for binomials, we know sigma is root np1 minus p, right? But that's not the variance, that's the standard deviation.
So squared.
So square it, yep, sigma squared is np1 minus p, and so I'm not gonna have any roots in this thing yet. Does that make sense? So that's 10 times 0.5 times 0.5 again, right? Plus 20 times 0.4 times 0.6, which works out to be,
2.5 plus.
I somehow got 7.3.
Well, no, just I just did the first one.
Oh, yes, I see, uh-huh.
Plus.
Anybody get it? I just trust myself. And teacher doesn't have a calculator, so I'm screwed. What'd you get? Did you do it?
Manuscript.
7.3.
I got 7.3. I should trust myself, but yes. And then how about the standard deviation?
Square root of
Mm-hmm. Will be root 7.3, which is about 2.70. So the only tricky thing in that one is you had to use the unrooted stuff, right? I'm gonna do B and then I'll just skip C because you can just look at my notes online that have it. But B is also normal, so it's a bit different. Okay, so we have X is a normal random variable with mean mu equals 100 and sigma is 15, and Y is also normal and has the same mean and standard deviation. So first of all, when you add these together, normals are special, you're still gonna be normal. Okay, the mean of X plus Y is just the mean of X plus the mean of Y. This one's really easy. 200, exactly. The variance of X plus Y is variance of X plus variance of Y. So what's X's variance? Is it 15?
Oh, it's 2.5.
It's 15 squared. Does that make sense? How about the variance for Y?
15 squared.
Also 15 squared. So that comes out to be 225 plus 225, which is 450. So what is the standard deviation of X plus Y then? Square root 450, which is approximately 21.213.